but seems to be good now. Okay, so my overall plans for today is I'm just gonna first I'm gonna just like create a battle, and I'm gonna just like sort of talk through the AI um, and what it's doing and what it's thinking at every moment, and then I'm gonna sort of I'll tab over into Visual Studio and show you where that where each bit of AI is modifiable in the code. So the basic goal is just to give people an overview of how the AI works from a kind of a high level, so that they'll understand which action they actually want to modify to get their desired effect, and also to give people kind of like an entry point into the code, and so they can know what to look for. So the first basic thing you want to do. Oops, they're too far apart. The first basic thing you want to do in terms of AI is turn on AI debugging. So the game has a pretty in-depth AI debugging feature. You just type debug AI like that in the console, and then if you select the ship, it pops this little window up, and you can see what it's thinking. So that's really critical. Really critical AI debugging feature. So I'm just gonna take a minute and step through all these actions and explain what they do, and explain how the general system works. So the AI in Reassembly is based on something called an action list, or a behavior tree. There's a lot of different names for it. If you search for action list or behavior tree, you'll get a bunch of talks and GDC presentations and stuff describing how these things work. There's a lot of it's kind of a general concept, and there's a lot of different details. But basically, there's a list of actions, and you can see all the actions here. There's like a avoid cluster, a fallback target, a target defense, a target enemy, a weapons, etc. These are all like different actions, and in the code they're implemented as classes. There's like a action interface, and then we generate a list of actions. And the way it works is that the AI starts running through the actions, and each action gets a chance to run, starting from the beginning, and then basically it can decide to run or not. It can decide if it has something meaningful to do or not. And if it decides to run, it can block further actions from affecting the same thing it affects. So there's this concept of lanes. So we have like a bunch of different kinds of actions that affect different lanes, and the lanes are I think there's 4 lanes. They are in let me find where they're defined. So here in the code, right here, you can see the different lanes, and they're implemented as a bit field. So when you see these numbers here, it says like 1, 1, and then like 4, and then like nothing, and 4, 4, 2. These numbers here are just like the bit fields in the lane. The bits, this is like the bit mask of lanes that are being So the first number here is the lane that affects the action. So the action will not run if a previous action is already running in this lane. And the second number is the lanes that are being blocked by this action. So if you can see that here, like lane movement, this one shift 0 is 1, and lane shoot, this is 2, which is 1 bit shifted to the left, one bit. Lane target, so let me just put some numbers here. If you're not intimately familiar with bit manipulations, so basically, the high-level explanation is that we can have like one action moving, and we can have a different action shooting at the same time, because ships can like move in one direction and shoot in a different direction. And similarly, like we can be targeting while we're moving or something like that. But like if one action decides to do movement, then another action can't move. Also, like fire the thrusters, right? Only one action can fire the thrusters at a time. So a avoid cluster is this is like the dodging other ships action. It basically looks around for nearby ships and if the ship is about to like collide with another ship, then it will fire the thrusters to try to avoid the collision. So we can see that that's firing right now, and you can see there's also a star over here, and the star indicates that the action is running. So you can see that none of these actions, like for example, action attack, which is the main sort of tactics movement, it's not running at all because right now it's being blocked by action avoid cluster, and that makes sense because you can see this crescent ship we're looking at here is crashing into this other ship. It's like almost crashing into it, so we would expect it to be trying to avoid it. So a avoid cluster here is setting that movement lane, and that prevents further movement actions from running. And then so the next action is a fallback target. So this is interesting because this action is it's running, is indicated by the star, but it doesn't have anything to do, so it's not doing anything. And we see that a target enemy down here is the one who's actually setting our target. So a fallback target is responsible for setting like the so-called fallback target for the AI. AIs actually have 3 different targets. And I think we can see the target here in the debugging, AI debugging. Actually, it's like our main target here is this 8 Grape Cruiser, which is this thing, and it actually draws like a red circle around it, which is convenient. So like this, if we look at the Grape Cruiser's AI, actually we can see a fallback target. The Grape Cruiser is actually targeting this ship. It's targeting this ship primarily, and then the fallback target is the crescent ship. I think, right? You can see the fallback target is the crescent. Actually, the target it looks like actually they're both targeting the crescent. These other lines are from they're from point defense cannons, I think. But basically the idea with fallback target is that there's often a situation where the AI is like sort of strategically targeting one ship, but it can't actually shoot at that one ship at the moment because it's not close enough or something, and then we might want to shoot at like a smaller ship that's nearby, just because we prefer to shoot at something rather than not shoot at something. So the fallback target is useful in this kind of situations. And the third target. So I said that earlier that the AI has three targets. There's like the priority target, which is the sort of like if you're for example, if the AI is for a follower ship and it's following the player ship in the campaign, the priority target is like the target that the player is targeting. And in situations like this where there's no player, I think the priority target can get set, like there's the sort of parent-child relationship between the ships, and the priority target can be the ship that the parent is targeting. So that's the highest priority target, and then the sort of normal target is the normal priority target that each ship sets for itself, and then the fallback target is the lower priority target that we will shoot at if we can't shoot at the main target. Okay, so the next action we have running is a target defense, and I can't remember exactly what this action does. I think it does something like targeting ships that are shooting at us. There's sort of like an AI mode system, which I guess I can explain right now, which is related to defense. So the AIs have three sort of like they have 3 modes in the code. It's called an AI mode. Let me see if I can figure out where it's defined right here. AI mode, and so the three AI modes are offensive, neutral, and defensive. And the way this works, the reason for this system basically is that the AI has sort of like AIs will sometimes initiate attacks, and then the AIs will also respond to attacks. So if you attack another ship, basically we're trying to avoid a situation where 2 ships are defending against each other. So if you shoot at a ship, then it sort of aggroes against you, so if you have like an offensive posture and a different ship and you shoot another ship, that ship will get the defensive posture, and then that means that if you at some point later decide that you don't want to fight that ship anymore, you'd like to leave, but it's already, you're sort of aggroed against it because it's been shooting at you. You can switch your posture to defensive, and if both ships have defensive postures, then they will stop shooting at each other. And then neutral means that you're not shooting at them at all, so you're not aggroed. So I think a target defense probably means set the defensive target posture mood based on people who are shooting at us. So in a target enemy, I think we're in the sandbox, so I don't think resources are enabled, which means that it's sort of like tournament mode. So a target enemy just means like, do you have a different faction number than me? And if so, target them. So targeting is actually one of the most important elements of combat because everything else is kind of based around it, right? Like you have this idea of this one target that you're trying to fight, and depending on who you target exactly, it depends. Like for example, your movement is completely based on where the target is. So targeting is actually really complex, and that's why there's so many different targeting actions. And I think for people who are interested in modifying tournament AI, like targeting is one of the big things you're going to want to look at. Probably almost more than like actual like low-level movement. Okay, so in this situation, we can see that a target enemy is active and it's blocking future targeting actions. The next action is a weapons, and that's responsible for actually firing all the guns on the ship. It actually like it iterates through all the weapons, and it turns the turrets and stuff like that, and it handles charging weapons and all those kind of things. So you can see it's in lane 2, and that's the weapon lane. I think there's other actions that use weapons, but that's the main one. I doubt that this a weapons is very interesting for modders to change, because it just basically shoots the guns in a sort of relatively optimal way at the target. I mean, I guess it handles things like leading shots, which you could presumably modders might presumably want to change, but it's fairly like low level. So we can see here in the comment that it's enabling, this crescent is enabling 6 different weapons, and it's firing at the main target. So if it's firing at the fallback target or something like that, you'll see a different comment here. So the next action is a runaway, and excuse me. You can see the way this works is that there's like a kind of a quorum sensing thing the ships do, and this is something that's much more important in the campaign than in the in tournaments. I don't think it's really important. It's not really used in tournaments at all. I don't think this action is even injected in tournaments. But basically, it counts. It figures out this ratio of like friendly ships to enemy ships, and if the ratio is like too extreme, then it will cause the ship to run away. Because we don't want to we don't want to just suicide. Okay. Next action is action attack. This one is really critical, and this is the action that actually basically causes the ships to maneuver relative to each other. And like when people talk about like execute behavior in the AI, that's actually kind of an artifact of action attack. So action attack has the way it's implemented in. Let me let the ships move a little bit so we can actually like see some of these actions activate. Okay, so this ship just got this big this grape ship just got completely destroyed, and our crescent now is it looks like it's doing some kind of pathing thing towards the target. So let's see what it's thinking. It's not avoiding the cluster anymore. It looks like it's firing some of its weapons at the main target. Okay, so it wants to attack, but it's obstructed. So it's noticed that there's a big like a big piece of debris between our ship and this other ship, and it's trying to path around it. So this is one of the this is the reason for the action list, and this ability for an action to like do something if it has the if it knows how to do something intelligent, and if it doesn't know how to do anything intelligent, it's just going to punt and hope that a like later action can do something intelligent. So basically, the actions the action list runs from sort of high priority, like really simple things to like low priority, complicated things. So actually, the action that's actually moving our ship right now is action investigate, and action investigate is in charge of like movement that action attack can't handle basically, and that includes like, for example, if we have a target but it's like out of range, or like if the target is obstructed and we need to path around it, or if like in the campaign, investigate will, like, if it sees some projectiles, for example, and but it can't see the ship that fired the projectiles, it will like fly over there and see what's going on. So you can see these purple pathfinding circles show you where it's trying to go. Like, it looks like it's trying to go here, and then it's trying to go there, and then it's trying to go over here for some reason. It's kind of futile given that all these ships are moving around super fast, but it will kind of cause it to, in general, move this way, which is going to, get it around this grape debris anyway. Let's see. So I'm going to run it again for a sec, and so we can see that well, the debris got completely destroyed by that nuke, but it also has a new target now. It's now targeting the photonic mothership, and it looks like it's trying to avoid cluster though. It's probably trying to avoid this guy right over here. I'm trying to get it to actually run action attack. Okay, so its action attack is now in force, and I think so. Like, this orange circle is actually describing where it wants to be for action attack. So action attack, I actually want to jump into the code for this a little bit, because this is one of the I published a GitHub repository with most of the code for action attack yesterday, because I think this is one of the main ones that the tournament AI people will want to modify. So action attack is primarily concerned with maintaining like a certain distance away from the target, and that certain distance is dependent on like the ranges of our weapons and the ranges of the enemy weapons. And so let me jump into the action attack code really quick. So this is the tactics AI. This is the source for the tactics AI that I published on GitHub. So it has code for a target enemy too, which is basically just a target enemy, but I renamed it to avoid any kind of simple problems. It's exactly the same as a target enemy. Maybe I'll go over that afterwards. But right now I want to look at action attack. So let me show an overview of the action AI action class actually. So just so you can see all the entry points. So this AI action class is the base class for all AI actions, and so every one of these guys is an AI action. And so like there's a lane. I already went over the lane. So as a constructor, it has a handle to this AI struct. So this AI class is like basically like shared data for the AI. So it's basically attached to the command block on the ship, and it contains all the information that all the actions need to access. So if you're going to do anything like look for nearby ships, or if you want to manipulate the command block, or if you want to look at any of the summaries of nearby ships, or anything, you need to anything that's not in your action class, you need to go through this AI struct. So this is finished is something that you can set to sort of delete the action. So some actions have temporary behavior, and the actions can also create more actions, and the whole thing can be kind of dynamic. And a lot of action list oriented AIs are very dynamic, and they build a little list of actions, and then some actions will create more actions and stuff. In Reassembly, usually the actions just stick around for the whole. They're just kind of hard coded. But if you want your action to quit, you can set this to true, and the action list will remove it. So this is a mask. This is the bit mask of blocking action lanes. So the action list thing looks at this when it's executing. This gets set by your update action, and but But basically, you shouldn't change this stuff. It gets changed by the system. There's some priority in tag and things, but it's not that important. This is the main function, this update function. It gets called every AI tick, and you get to like make decisions about what to do. Is there any more stuff? A lot of this, so this stuff is all related to the, displaying this nice pretty list here we have here. If you're trying to debug your action, you probably want to make it. You might want to just make it display some like little helper text in here. That's very useful for debugging. You can also, this is also a render function where you can draw. That's where all these like lines, all these helpful debugging lines get drawn. So you might want to do that too. But you don't have to. Let's see. This is just some helper-based class stuff. Okay, so let's go back into the action attack. So this is the source for action attack update. It goes from line 125 to line 212, so it's about 100 lines long. I guess I can just go through the code slowly and explain what everything does. It's let's see. So this gets the target. So like I said, in the AI, this MAI struct is where you get. This is how the actions communicate. So this MAI target is something that gets set by the targeting action. And we're calling get here because like this target is actually it's a kind of a C++ smart pointer. And if you're not familiar with C++ smart pointers, it's a kind of object that looks exactly like a pointer. And I guess if you're coming from C# or something, you don't even know what a pointer is. It's like a reference, right? I mean, in most modern programming languages, you don't have direct access to pointers, but it's just like you can just think of it as it's a variable which it points to the target. So this is a reference to the command block of the target, and the watch pointer is I can show you where it's defined. It's maybe it's in here. Is it? Did I turn on caps? Did I turn on something weird? Here it is. Okay. So this watch pointer. The watch pointer is this is the AI struct. Looking at the AI struct. So it's a huge class. It has tons of data. So this is the target, the fallback target, and the priority target I was talking about earlier. So the watch pointer is it's a kind of smart pointer, and so C++ is not garbage collected, unlike on C# or something. So you actually have to like delete stuff when you're done with them. So people often use smart pointers for that. It's like a class that basically behaves exactly like a pointer. Like so, it's almost exactly the same as if you had just written const block pointer target like that. But the difference, the watch pointer is something that I wrote specifically to handle this reference problem, which is that if the target basically blows up, this gets turned into null automatically. So if this block gets destroyed. And obviously, this is something that happens frequently. Someone else will shoot your target, and then this gets turned null automatically. So you have to check that it's null before you use it. Somebody's asking about the GitHub file. Yeah, I posted a link to it on Discord. I will when I post this video on YouTube, I'll post a link to that too. I can put a link in the chat really quick. Let me do that. So I put a link. It's also linked. This is the main. So this is the main mod AI GitHub page, and I added a link down here to there's two examples. One that uses guns as thrusters, and then this one, which is the one I'm going through. And here, this is posting it in the chat. Okay. So I recommend that you either check out this base one, and then just like copy paste code from the other one, or you can fork one of the other examples. Whatever you want to do. Okay, so we're looking at the target, and then we're going to call is target obstructed, and I'm not going to go into the implementation of this, but it checks to see if the target's obstructed. We saw that happen earlier, where there was something in between it. It does some spatial queries, and presumably it also checks to see if the target is null. And I think it returns false if the target's null because we're not checking it anymore here. Okay, so next we're going to get the nav config for the target, and this ties into the nav config is kind of like a low-level thing for dealing with thrusters. So there's this whole like sort of nav subsystem, which gives us a slightly high-level interface because like obviously flying the actual ships around is very complicated. It involves turning on and off like potentially hundreds of thrusters, and we have to keep track of like which way the thrusters are oriented and stuff. So this target config, I think this is part of the enemy. Oops, it's part of the so it's actually cached here. So this sn config dims struct it stores basically it stores the position and velocity and the angular velocity of the target. So just where it is in space and how fast it's moving and how fast it's rotating. So when we're actually changing our velocity, sometimes we want to say like move here, but we don't care how fast we're going, or sometimes we want to say like I don't care where I am, just move to this position. I mean I don't care like where I end up, I just want to be moving this speed. So it's important to like know which. That's what the dims field does. It allows us to to say which of those fields we care about. And there's also this SN precision, and the precision idea is the idea is that like we want to get within a certain like precision of the nav config destination. And so like when we see this radius, like there's this huge circle here. I think that's a rendering of the position of the precision. Because we often want to be able to say like we've arrived. We want to say like we were trying to go to this destination. Have we arrived or not? And it's very hard to exactly hit like a very specific point because like of all the physics. So as long as we get like within some circle of it, we want to say we're done, and then the next action can take over. So that's what the precision does. Okay, so now we're going to get this command block. This is our command block, the command block of this crescent ship, right here. And then this is a handle of our cluster. So I guess I should say the blocks. So block cluster is basically a class which represents all the blocks that are connected together. So your ship is one block cluster, and like missiles, for example, each have their own block cluster, and then every block is a block. Somebody's asking if we need Visual Studio for this. Yes, you need Visual Studio for this. There's sort of, in theory, there's no reason you can't have mods on a Mac, but in fact, we haven't implemented any of the DLL loading stuff on Mac. It's only for Windows, because, at least according to Steam, about like 97% of people or something are on Windows, and so if you're gonna make a Mac mod DLL, then like not very many people are gonna be able to load it anyway. So I'm sorry. I actually do most of my development on a Mac, but it just didn't make sense to do all that work for all three platforms. Okay, so next thing is this attack capabilities, and this attack capabilities is when I was talking about earlier, this idea of a summary of the enemy ship. So like, and reassembly AI is like really hard to write because the AI like has to figure out what your ship can do and what kind of ship you have, and also what the enemy ship can do and what kind of ship they have. Like it's really difficult. Like I mean, everyone's complaining like, oh, the AI is like for my ship like is being really dumb, and why is it doing this dumb thing? It's obvious to any human that it should be doing something else, but it's really hard to, in the general case, to say like, given this like player defined ship with 500 blocks and this other player defined ship with 500 blocks, like how should I behave? It's it's hard to figure that out automatically. So anyway, the attack capabilities is part of how we try to do that. So this is something you can see here that this is a reference. This is another C++ ism. This means that it's not copying the entire struct. And like when we say get attack caps, a bunch of different actions use this data, and it's actually like reused across the actions. And I think we're careful to only recompute it like occasionally because it's expensive to recompute. So So when we say const reference is a kind of a C++ idiom for saying like I would like to look at the data, but I'm not gonna copy it, and I'm not gonna modify it because it's const. I just want to look at it. So you can see here like that, like we're looking at, this is MAI, this is our attack capabilities, and then we're going to look at the target attack capabilities, right? We say target command AI, so this gets command AI gets a reference to the AI struct for our target, and then we're going to look at the target attack capabilities, and then we're gonna like make decisions by comparing these two things. Obviously, if we don't have any weapons, then there's nothing to do. So we return, and hopefully some future action will be able to figure something out. So let me look at the attack caps definition really quick. And I should say, like, please, like, if you have any questions in the comments, I have no idea how much of this is either too obvious, or if I'm going too fast. So please ask questions or interrupt me if I'm not explaining something enough, or if it's obvious. So the attack capabilities keeps track of, like, this is like the bext range, the max range. So this is like, I think it does something fairly complicated, and it tries to figure out the range for which most of our weapons, like with the range for which most of our weapons will be useful, but like it's like trying to find the longest range where most of our weapons are still in range, if that makes sense. So max range is like the range of our very longest weapons. So best total DPS is our like maximum DPS. I think rush DPS is like, I can't remember what the difference between those two is. Let me look really quick. Okay, so rush DPS does like not include launchers, and total DPS it does include launchers. And I think the idea here is that like, so this is the code inside Reassembly where we actually compute this thing. See, it goes through all the blocks and adds various things up. Like if it's a shield, we add our health and regen and stuff like that. Computes the range. So the autofire DPS is our point defense weapons. I think it uses this in the action avoid. There's an action avoid weapons. Why is that not even firing for this guy? Yeah, A avoid. Yeah, so A avoid weapons. I'm not sure why this guy does not have A avoid weapons activated. Maybe because he's too big and heavy or something. But A avoid weapons is this is the action that does dodging of projectiles. So that's a really important one. And it like as many people have noticed, adding missiles is a very effective strategy in tournaments because it's very distracting to the enemy ships. And what they're doing when they're distracted is running A avoid weapon. That they're trying to dodge the missiles. And so like I think this autofire DPS gets used by A avoid weapon if it sees a bunch of missiles incoming, but it decides that we can like probably shoot them down, that it will like try to avoid getting distracted. There was a period early in development when people were complaining wildly about the tournament AI and stuff, and I was trying very hard to make it better and make it get distracted less. Let me see. So Cambo's asking what is rush DPS. I'm gonna go through the action and I'm gonna go through. So rush DPS it represents the damage we can do, not including launchers, and the idea is like the damage we can do immediately. Like we don't like launchers might be regenerating, and we don't want to like charge in, ready to execute the enemy, and then it turns out our missiles are still regenerating. But I'm gonna go through the action attack. I'm gonna go through all this code slowly, and then you'll be able to see what all those values do. What was I saying? Oh, weapons. Weapons is a bit mask of all the different kinds of weapons we have. Hasfix keeps track of whether we have any like spinal weapons, because that spinal weapons are like really hard for the AI to deal with, or anyway they add a lot of constraints to the AI because the whole ship has to be pointed towards the enemy, which is not a problem for ships with only turrets. So total health and health regen are are the health of our ship, and we use those when we're trying to decide whether we should like charge in and shoot them or kind of strafe. And then this max accel is our acceleration. And obviously, like, you can't represent like your acceleration meaningfully with one float because the ship might be able to accelerate really fast forwards, but like not backwards or something. But we just we do something and we try to summarize it. Just reading comments really quick. Someone's asking about excluding weapon blocks that are manually flagged as point events by the player from the AI weapon range calculations. Yeah, right. I remember that comment. So you want to modify this attack caps thing, and I think oops, we can't modify that in here. So this obviously this code get attack caps is in reassembly. However, you're free to not use this and ignore it and or recompute it. I think I posted the code for this on the paste, whatever it's called, some kind of pasting website where you can see it. And so you can see it's actually just returning this m attack caps, and here it creates a reference to it and fills it out. So it's cached within the AI. So if you really want, you can just modify this. You can just create an action that just like modifies m attack caps, right? That runs before a attack, and then it'll use those variables instead. Or you can replace action attack to just like compute that action. Oops. You can rewrite this attack 2 code to just not use that, to use whatever range variable you want. So you have full access to your entire cluster and also the enemy cluster. You can do whatever you want in here, and compute all those things. So let me run through and talk about how it actually computes the values. I think it'll make it a lot more clear than just looking at the struct definition. So let's see. So here we're just loading. This is cluster get absolute position. So there's all these different positions that are relevant. This is going to return the center of mass of our ship cluster. So cluster get absolute position returns the center of mass of our ship. So let's see, who am I? I'm looking at this guy right now. So that's going to be like here, like in the middle of these circles. This is position right there. And the differences between these things are like not important for missiles, but they're really important for large ships. Okay, so the target position is the center of mass of the target of the enemy ship. Target velocity is the velocity of the target. So these float twos, by the way, if it's not clear, there are vectors. They have an x and a y. And target distance. So okay, so we're going to say target distance between target position and our position. So that's the distance between the centers of our two ships. So that's like this, and it looks like this is the target, I think. So that's this length right here. And then we're going to subtract one half of the target core radius. So the core radius, there's like several different radiuses that are relevant. The core radius is like this smaller circle. Which is, there's like the biggest, this is the bigger one is the like total bounding radius. You can see there's like no blocks that are outside of it. The core radius is like, it's trying to guess a radius like inside of which is basically solid blocks. And the core radius is like a safe thing to shoot at. We know that if we shoot at the core radius, we'll probably hit something. So like if we click on this guy, you can see that this is his bounding radius and then his core radius. So if we shoot at the core radius, we'll definitely hit something. Okay. Okay, so here we're gonna calculate our DPS and the target DPS. So it looks like, so we're gonna say my DPS is our rush DPS. So this is our DPS without missiles, and we're going to divide that by the target's total health, and then their target DPS divided by our total health. And so this is kind of like we're trying to compute like basically who can kill the other one faster, and we're going to make some decisions based on who has more DPS. So someone's asking me about if it's possible to do the things I'm doing on a Mac using Visual Studio for Mac. I don't know. I have not used Visual Studio for Mac. It's probably possible for you to it's probably possible for you to basically develop your mod on a Mac and then just sort of copy it over to Windows to compile it and test it. I mean, obviously you can just use a text editor on the Mac to write the code. I mean, if a bunch of it's not like an insane amount of code to load the DLLs and stuff. A bunch of people bug me about it. I can probably implement it, but if it's just like one or two people, and the thing is, like, you can't really publish your mod on a Mac because like none of the players have Macs, so it really needed Windows to actually like deploy it. But I don't know about in terms of just developing it. Okay, so the next thing is AI config flags. The heck are these flags? Oh, these are the serial command flags. So these come directly. So those of you who are familiar with modding, probably have seen these serial command flags. So like, where are the flags? There's a list of them here. So this is like the cautious, social, peaceful, wander, etc. There's a bunch of these that go into constructing the list of action lists. So this AI attack action is gonna it's gonna decide between like three basic strategies, and if you're familiar with tournaments and you can see these strategies in the tournament text. There's like rushing, kiting, or apparently I renamed it sniping, and maneuvering. And so rushing involves like flying towards the enemy really fast. Sniping involves trying to stay out of range of the enemy weapons, and maneuvering involves sort of something in between. So let's see. So we're going to compute. We're going to say like we want to. So this we're going to compute this variable rushing, and it's like if our DPS is like greater than the target DPS. And remember, these DPS values are normalized for our health. So basically, this is saying like if we can kill the other guy, a little bit faster than he can kill us, or the flags say always rush, or the flags don't say always maneuver, then this will be true. So snipe range is like slightly longer than the enemy's max range. And then we're going to say, can we stay out of range? Okay, first of all, is our weapon range longer than that snipe range? Secondly, is mobile. This is basically just false for stations. So can we actually move? And then we have to say, okay, can we actually do more damage than they can regenerate health? And then this means and the always maneuver flag is not set. So these things, this thing, if you haven't programmed in C++ much before, done things with bit fields, you might be confused by these ampersands. Flags is this is like a uint64, right? So it's a 64-bit integer. It just contains 64 ones and zeros, and so these things are bit fields. So as you can see here, they have values like this is 1, this is 2, this is 4. So we can store all these different flags in one 64-bit integer very efficiently. And so when we say and, this does like a Boolean and the result of this will be like 0 if the always maneuver bit is not set in flags, and it will be something that's not 0 otherwise. So someone is asking, do rush DPS, total DPS, etc. Change as the ships take damage? Or do they just assume the ships are always complete? Right, that's a great question, and I'm glad you asked that. So yes, they do change. So the fact that they change is the origin of the so-called like execute behavior. So what happens is that as the ships get destroyed, they reassess each other's capabilities, and if the target is getting really destroyed, then this rush stuff will start to be true, and the ships will run in and try to execute them because they suddenly realize they can execute them. So if you want to avoid that, like, I mean, I guess you could just get rid of that and just cache. You could just cache it in your A attack too, right? Like we could just say when it starts up, just set, if our attack capabilities are not set, just set it, and then just reuse the same attack capabilities for the target. you could just do that, or you could change this other stuff. But I think, I mean, you know, it's sometimes important to change it, to take into account the fact that the enemy ships are changing. Okay, where was I? Here's my comment to myself. 20 magic numbers. Right, so this is the thing where we actually decide the range we want. So if we're rushing, then we want to be like right on top of them. If we can stay out of range, then we're gonna try to like stay within snipe range. Otherwise, we're gonna stay like slightly within our best weapon range. So here we can see soon we're gonna see the nav config stuff come back into play, which is how we define where we want the ship to be. Let's see, target lead position. This is where the target is going to be in a minute. So this is a great time for me to talk about the time steps, actually. The AI does not tick every update step. So reassembly, let me just back up a little bit and describe reassembly's view of time. Reassembly has like basically two decoupled threads. There's like a render thread and there's an update thread. And so it doesn't really, it's not very meaningful to talk about game actions in terms of frames, because frames are something that affects the render thread. And so if you've ever like flown into spiky plant territory and you see the frame rate is like stays pretty good, but everything starts happening in slow motion, but like very smooth slow motion. What that means is that the update step the update thread is getting behind, and the render thread is doing great. So the update thread tries to run at 60 frames per second. There's an option to make it run at like 120 frames per second, for example. You can change it, but the AI doesn't not run that quickly. It does not. I mean, it doesn't. We don't need to make these kind of decisions like every frame, right? It's unnecessary, and it would be very inefficient. In fact, the AI already is like one of the slower parts of the game. Especially things like pathing can be like they can be kind of unpredictably slow, and cause problems sometimes. But so anyway, the AI is implemented in terms of like 3 different time steps. So some of the AI runs. Let's see. Let me go here. Okay, so there's the AI time step, the big time step, and the super time step. And I think these are CVARs, I think. So you can change them. Okay, so the normal time step is every 1/10 of a second, and then big time step is every 1/2 second, and then super time step is every 5 seconds. So I think like action metamorphosize or like action reproduce, for example, the actions that are responsible for spawning more ships, they probably run like super time step, because it just has to happen occasionally. And then big time step is like for sort of I think like pathing might get recomputed every 1/2 second, something like that. So all the AI, like all this AI stuff I've been showing, like it doesn't run every frame for every ship. It runs like, I think there's a whole system that will kind of like spread the AI updates out across different frames for different ships, so that they're not all happening in sync. But where was I going with this? I think here in this target lead position, we're just kind of like, I think I'm not really using this variable here as like it's not precisely referring to the big time step, which is 1/2 a second. It's just kind of like, it's a conveniently sized number, because we want to, a 1/2 second is like, it's reasonable to like shoot for where the enemy is going to be in 1/2 second. It's like about the right amount of, it's just like a variable which happens to have about the right scale. So when we say target position plus this, I mean, this is referring to where the target is going to be in 1/2 a second, assuming that they don't change velocity, which obviously they will, but and then target direction is a vector from our position to the target position. And so it's normalized, it's a vector with the length 1, right? That's what normalized takes vectors and makes them have length 1. So we're going to set this rush direction to target direction. I think this gets used by some other action. I can't remember which other action, but I think it might be the action avoid weapon, actually. That's the dodging bullet. This is the dodging bullet action. I think it will cause it to just like run through their bullets instead of trying to dodge things. because otherwise, if they have like one little turret, they can avoid this happening. This kind of rushing behavior is really important for like I think this was implemented for like ships with like proton swords. Like there's some ships that have these like super high DPS weapons, but if they're not like really decisive, the enemies can just kind of dance around them and pepper them with missiles for hours. So they have to really like ignore the enemy weapons if they decide that they have the DPS to health ratio. Let's see. So direction. Let's see. So if we have a fixed weapons, then this this function will point us at the enemy, and it's looking at the position and the target velocity. So this is gonna. I think it actually like figures out how fast the projectiles on our guns are moving on average, and then it like points us in such a direction that our shots will hit the enemy, assuming they keep moving at a linear speed. So otherwise, we're just going to kind of face the target. So now we're going to fill out our now we're going to fill out our nav config, and then we're going to pass this off to the nav subsystem which actually turns on the thrusters. So we're going to say we want to position is we want to be moving. We want to set our position to the target. This is like where we think the target will be, and then we're going to subtract the direction and then the range that we want. So, and we can see that I think is this guy running action move? I don't think he is. Let me find someone who's actually running action attack. It's so he's obstructed. Okay, so so right now action attack is actually running, and this is where we want to go, and this is that position, right? It's like where this guy is going to be. This guy is I don't know which way he's moving, but this is that position right here, and then our velocity is going to be set to like 95% of the target velocity. So we want to match speeds with the target. This is really important rather than just like setting it to 0 or something, because like if we're trying to like kite enemies, we need to move at their velocity, and and we're going to damp it slightly because I think otherwise like there are some problems if you set it to exactly the same, then they'll like sit slightly out of range of each other forever. Someone's asking, is it possible to make more AI behavior profiles? I assume you mean this like rushing, sniping, maneuvering. Yeah, I mean you have the code, man. You can rip all this stuff out and do whatever you want. You can make lots more profiles. If you're asking about these serial command flags, then no, you can't add more. Because it's a bit field. I think, where is it? Where is it defined? So this is Reassembly uses bit fields for everything, and it's cool because it's like very compact and stuff, but it's like kind of not very extensible. Because they're bits. Like we've used 30 bits. I guess if you really want, like you can use the rest of the bits. Like it's 64-bit number, right? So you can use like you can just calculate what like 1 to the 30 shifted 31 bits over is, and then you can set that. And like when you're setting the flags in the blocks.lua, you can actually just put a number instead of like usually it looks like, usually you would write like mutates or dodges or something like that. But you can actually just say or like 0x like whatever, and so if you really want, you can do that, and then you can make your AI modify it. But like honestly, like this system is kind of not that great. Like this, these things are like really hard. It's really hard to understand what they do, and they don't have a one-to-one correspondence with AI actions, and like I think a bunch of these like aren't even really that used. Like some of them are a bunch of, like children's set and blue pit set are used, and like some of these like fire at will is used by the player fleet command system. So some of them have good meanings, but I think like if you want to change the way the AI works, you should just use the code. It's so much more flexible. or is I, okay, so let's see. We're going to set the precision. Oh, okay. So I just talked about the target config velocity, target config angle, which is like, this is like what direction we want to be pointed in, and then it's just the same direction, which is for fixed weapons or just pointing towards the enemy. And we're saying we care about the position, we care about the angle, and then if we're rushing, then I think like SN target velocity means, this is like something that missiles use also, and it means like we care about the velocity, but like ignore the velocity of the objects moving together. So like rather than like, I think it takes like the dot product of the enemy of the target velocity and our velocity, and like somehow erases that from the velocity delta somehow. So it means like match like hit them, match velocities with them, but like you're allowed to like move really quickly towards them, but just but don't like move really quickly like to the side or something like that. So otherwise we can actually care about this velocity. So we want to arrive at this position going this speed. And so the precision is like, we're saying that's, I think that oops, that's the size. The precision is the size of this circle. I think this entire circle might be like our max range or something like that. But so anyway, the precision is like a fraction of our weapon range. Let's see, if we're sniping, there's special escape super fast code. When I was writing a lot of this, it was like around the time we very first started doing tournaments. I think like I was like running these tournaments like either during or right after the Kickstarter. That was like 3 years ago, and at the time, like the tournament ships were like there were these like proton laser ones that would try to like rush you down and incinerate you immediately, and there were also these like sniping ships, and it was really important that the sniping ships thrust backwards as fast as possible, away from the proton sword ships. So I think that's what I was thinking when I wrote this, and I think what this basically says is, if we're sniping and the distance to the target is less than the range we want. Like, so if the target is too close and we are very uncomfortable, then we're gonna set the velocity to be like just like, this is like literally just a way, like this is the target config position minus our position. So just set our velocity to like super fast, go away, and in that case we don't care about the position. So it's not going to try to like move to this particular position. It's just going to thrust like backwards, super fast. And then this SNVal allow rotation flag is so like certain ships like have trouble like rotating and also like translating using their thrusters at the same time. So there's always like kind of a like, you know, it's a kind of a trade-off. Like we can either point in the direction we want to be pointing in, or we can like be translating in the direction we want to be translating in. Like certain ships, for example, like basically have to rotate and then move straight. And they can't just like move sideways. So I think what this says is like, okay, it's like we want to move in this velocity as fast as we can, but it's like really important that we actually be pointed in the right direction. Like for example, if we have a spinal cannon, that spinal cannon really needs to be pointed in this angle. So just like do the velocity as best we can with that restriction. Yeah, so this is similarly, if we're sniping, don't worry about the position, just match the velocity. I think this is also has to do with directional weapons. Something about pointing in the right direction more aggressively. And then okay, so then we're gonna pass, assuming we have a good navigation system, we're gonna pass this off we're going to pass all this data off to the navigation system. So you say nav set dest, and then that will take care of turning the thrusters on and stuff at the appropriate time. And the other thing about the nav is that, like I was talking about the AI, it only runs every bunch of frame update steps. So the navigation runs like every update step because the thrusters need to turn on and off like pretty quickly sometimes. So that's one of the reasons for its existence. Right. Okay. And then, so that's action attack. That's how that works. I think. And you can see. I guess I'm just scrolling down the code, and it just occurred to me I should explain how to actually install actions. So if you checked out the GitHub account, you can see these AI add vanilla action. So this is how we add. This is how we get access to like these action classes that are defined in Reassembly source code. So I didn't want to just like copy all of the AI code and then put it in the and put it in the mods, because we don't like want the mods to include changes to things that they're not like actually meaningfully changed, right? Like if I add some like debug updates to these vanilla actions, I want to be able to publish that, using the same Steam publishing mechanism, and people won't have to update their mods. So that's why we can just call back into Reassembly to get the main actions when we're creating the list. But so what I've done here is I've just like commented this out, and I've added my own action and my target enemy action. And this add action macro, it just like checks to see if the action supports it, and then it adds it. It creates a new one. So it's just allocating a new action, and the memory will get handled by the AI system. And so this create AI actions function gets called to like create this whole list of actions, and it gets called basically whenever the ship configuration changes. So like if a bunch of your main weapons get blown off, we might want to behave differently, and so it reruns the create AI actions, deletes all the old actions, makes new ones. And so some of the logic about which actions should get installed is in these like supports config. Like here, like this is the action attack supports config function. So this gets called automatically when we create the action, and if it returns false, we like don't add the action. So for example, there's no point in attacking if we don't have weapons, and we also make sure we have fireable weapons, meaning that means like not auto fire, no auto fire weapons. The auto fire weapons have their own AI. So this is the I think this is a bit mask of like cannon, laser, launcher. Okay, so never mind, I lied. That doesn't talk about auto fire at all. That talks about like what other kind of weapons are there? I guess melee. I guess melee are non-fireable weapons. So it makes sure that we have weapons that it's meaningful for attacking to have. I get like explode, for example. I guess explode is a weapon, but action attack is like all about maintaining weapon distance, so it doesn't make sense to do that. And then a move is this is a base action for things that move around with thrusters. So this just checks to see if we're mobile, basically, I think. Right. So that's action attack. That's the main one. I think I've been talking for an hour and 20 minutes, so hopefully that is a pretty good overview of some of the AI stuff and how it works. Does anyone have any more questions? I could go over like some of these some more of these actions and explain what they do. I think that was the main stuff I wanted to cover. So I could just unpause the game and watch the spaceships blow each other up. Somebody asks what mutate does. Where is mutate? What does mutate? Where does it say mutate? Oh, you're talking about the serial command flag. Oh, this one. Oh, mutate. Okay. It looks. What is this? Okay, so this is an action but reproduce. So that's the action where we like spawn child ships and stuff. Let's see. Oh, this actually like applies the mutation. So I like. Yeah, where is this code? Anyway, it's this is like a. I think it like randomly changes the ship blueprint. This is something that this is not really in the game. It's like it's something I was playing with that's sort of incompletely implemented. But yeah, like it like replaces some of the blocks with different blocks, and it does it in a way that tries to preserve symmetry. And it can attach new blocks to the outside of the ship. So you can like mutate the ships a bunch of times, and they'll kind of like grow and stuff. Is there a mutate command? Oh yeah, I guess it's the same as that mutate command. Yeah, it's the same as the mutate command. It just does that automatically, but I don't think it like really works. It might crash or something. I always wanted to play with that kind of thing more, but it never quite had enough priority. And it's kind of like evolution is it doesn't really, it happens kind of slowly, and it's kind of hard to fit into the campaign and so on. Okay, so someone wants to add new AI actions which are globally applied to all ships. So you just want to, like, for example, replace the attack AI globally. Yeah, how would you do that? Let me see. I don't think it's really possible to do that right now. Oh, so here's how you do it. It's possible to do right now. So the faction data is loaded. I mean, the AI is loaded based on the okay. So this is faction data. This is the faction data struct, which this is loaded from factions.lua. You can see my fancy serialization system here. So basically, you set this AI mod AI name. Excuse me. You set this AI name to the name of your DLL minus the .dll. And so if you want to change the AI for all the factions, you need to like create a factions.lua that overwrites all the default factions and changes their AI name to the name of your mod DLL, and then that will change the AI. I think now that I think about it, it might be reasonable to create like a different API that allows you to do it like more globally, like a different mod entry point besides create AI actions. So I'll have to think about that. But for now, you have to change the AI name in factions.data. I guess the use case we were imagining was mostly like creating a new faction with special AI. And if you want to just do it for tournaments, then you can you can override it for the default faction or whatever. But I think it sounds reasonable to have a different entry point. It wouldn't not be like that hard to add. Anything else before I sign off? Okay. Well, thanks everyone. I'll be on the Discord channel if you have any more questions. I hope this is useful. Oh, one more question. Oh, you want to add AI profiles from the shipbuilding editor. I don't think. Oh, right. There's a way to do that. Right. So you're looking at. Oh, so you're looking at this thing. You can set the AI behavior. Rush kite dynamic maneuver kite. You want to add a new thing here, probably. There's no way to do that right now, but it's a reasonable request. So I could probably add something. It's not too complicated, but it's not possible right now. Somebody asked if I'm going to send any ships into community tournaments. It'd be fun. I'll probably get murdered. I'm sure you guys are much better at building ships than I am at this point. Maybe I could submit a custom AI that would cheat or something. I'll try. I'll see if I can get time. I always have a lot of things to do these days, but it'll be fun. And I watch the videos sometimes on YouTube. Okay, I'm going to sign off now. But I'll be on Discord a little bit, and we can chat in real time. All right, thanks everyone.